You know, I don't have such a trick, so let's invent one. To invent a math trick, we want to begin by observing. We're going to invent a math trick for multiplying numbers just above 200. So I've got several such products right here, 203 times 207, all the way down the list to 211 times 212. We want to pay special attention to how far away from 200 we are. So in 203 times 207, we're 3 and 7 away, and do we notice anything over here related to 3 and 7? Yes, 3 times 7 is 21, and that happens to be the last two digits of our product. But maybe that's just a coincidence, right? We need to go down the list and see whether that happens again. Well, 205 times 209 makes something that ends in 45, which of course is 5 times 9. And so on and so on. 202 times 211 ends in 22. 208 and 206 ends in 48. 8 times 6 is 48. 211 times 212 ends in 32? Okay, well, we'll come back to that. Now, it's all well and good to say we have the final two digits of our product, but there's a lot more product to go. So where do we get some of these other digits? Take those same two numbers. We were 3 and 7 bigger than 200. 3 plus 7 is 10, and if you double 10, you get 20. Well, that's interesting. I wonder if that continues. 5 plus 9 is 14, and if you double that, you get 28. 2 and 11 together make 13. If you double that, you get 26. And 8 and 6 together make 14. And yes, if you double that, you get 28. Now, come back to this last one. 211 times 212. 11 times 12 isn't 32, but it is 132. And also, 11 plus 12 makes 23. 23 times 2 is 46. But our two digits here weren't 46, they were 47. The way in which this deviates from the trick actually reveals to us the deeper truth of what's going on here. If we use a tool to group our multiplication, here's what we can tell. Our answers were always a little bit bigger than 40,000 because, again, we're multiplying two numbers a little bigger than 200, and 200 times itself is 40,000. 200 times 12 makes 2,400. 200 times 11 makes 2,200. And I can tell, oh, of course I'm just adding up the 11 and 12 and then doubling, because I'm literally doubling the 11 and 12 to get these values and then adding them together. But remember, in this case, we were off by 1. Those two digits there weren't just double the sum of 11 and 12. They were one bigger than double the sum of 11 and 12. The reason for that is 11 times 12 is 132, and so we do have the 32 here in our final two digits, but we have to essentially carry over the extra 100 that we generated. And so now, not only do we understand this nifty trick to multiply numbers just above 200, we also understand why it's working, and we can apply it in, hopefully, more scenarios.